Hi everyone! So today we are going to learn about microwave communication system. Okay, so what is microwave? In general, microwave is an electromagnetic wave that have small wavelength. Microwave's radio spectrum range across frequencies of roughly 1 GHz to 30 GHz. These correspond to wavelength from 30 cm down to 1 cm length. By definition, microwave is a line-of-sight wireless communication technology that uses high-frequency beams of radio waves to provide high-speed wireless connection that can send and receive voice, video, and data information. These are the uses of microwaves. Microwave radio transmission is commonly used in point-to-point communication system on the surface of the Earth, such as in satellite communication. Other parts of microwave radio band are used for radars, sensor system, and radio astronomy.
Concept of microwave communication. This is the basic building blocks of a microwave communication system. It includes a microwave radio transmitter connected to a directional antenna via a transmission line. The directional antenna's outbound signal is aligned to a distant receiving antenna which is connected to a radio receiver. Let's look more closely at the three building blocks of this link: the radios, the transmission lines, and the antennas. The radio. Each end of the link has its own radio unit, typically with both transmission and receiving capabilities. A typical microwave radio uses about 1 watt of power or less. A radio throughput usually ranges between 100 and 300 Mbps within a 50 MHz bandwidth, depending on the kind of modulation used. Throughput can be increased either by adding more data channel used by increasing the modulation scheme employed. Modulation scheme can range from low order QPSK to higher order QM or more. However, increased modulation reduces overall system gain, which has the practical effect of increasing susceptibility to interference and lowering overall reliability of the link in less than ideal conditions. There are three basic radio configurations used in microwave communication system: all indoor, all outdoor, and split mount. Next is transmission line. These are the physical media connecting the radio and directional antenna using cables such as coaxial cable or waveguide. Because of the amount of signal loss they can introduce, the choice of transmission line type is determined largely by the frequencies in use. Coaxial cable is suitable in application using frequency up to 2 GHz. Above this range, most lengths become too lossy to be practical use. Another one is waveguide, which is suitable for highest frequency. Elliptical waveguide features an elliptical cross-section and can support frequencies up to around 40 GHz. However, it is rarely used in application above 13 GHz. The antenna. A microwave system directional antenna is typically parabolic in shape, as this permits the greatest focus of energy possible in a single beam. They are usually polarized, vertical or horizontal, based on the location of their feed connection. The size of the antenna's dish is a key part of its design, function, and role within the network. Bigger antenna dish yield greater power, but they are more difficult to install and introduce limitations regarding tower space, tower loading, leasing costs, and local zoning regulations. Even though parabolic microwave antennas are highly directional, some of the signal energy is still lost to either side and behind the antenna. High quality antennas reduce this lost energy and mitigate interference, making them a worthwhile investment in spite of the incremental cost.
Okay, so now we are going to learn about modulation methods for microwave communication. Modulation is the process of converting data into electrical signals optimized for transmission. Digital modulation involves transmission of binary signals, which is 0 and 1. This method is divided into single carrier modulation, by which the carrier occupies the entire bandwidth, which consists of amplitude, frequency, and phase scheme that modulates and transmit different data on multiple carriers. Microwave communication system use phase shift keying method to convert its data into electrical signals for transmission. Phase shift keying method use the digital baseband signal to change the carrier phase but does not change the carrier amplitude of frequency. This method is an important modulation mode used by small capacity digital microwave transmission system. Furthermore, phase shift keying method also supports high anti-interference performance that is simple and cost efficient.
Now, we will look further into its technologies and applications. In a large telecom firm where people work with microwave, not the one in the kitchen, the one which transmits information, but without a cable. Microwave links are adapted to their surroundings to ensure high reliability, come rain or shine. Half the world's mobile calls are transported over secure microwave networks from one mobile mast to another. Different frequency bands are available to support different needs all around the globe. Next, from a telecom firm, we will now go into offshore operations. Over the years, for coordination from offshore to base between offshore installations with the pilots maneuvering short days, radio communication rules the routes. Today, communication which earlier was restricted mainly to voice mode has since undergone a sea change, and ONG have been at the forefront of embracing the latest technology in enhancing their communication system. As the demand for voice and data transmission, its quality evolved over a period of time. Banking on radio communication alone proved inadequate HF and VHF even though they have served them well for some length of time. But they could only handle voice data. For ONG, no large telecom service provider could be entrusted with data transmission services, where data security is of paramount importance. Thus, ONG decided to address its requirement through microwave-based communication network or microwave backbone, from offshore to onshore. By using this, they have been able to improve their bandwidth ability manifold from the existing 72 Mbps to 450 Mbps. Hence, they are likely to have a better data connectivity from the offshore to onshore. With this microwave base, the miles and nodes had shrunk between this base and the offshore field.
Analysis and discussion. A few properties of microwave that we can observe are: it is a wave that radiates electromagnetic energy with shorter wavelength. Microwaves also are not reflected by ionosphere. They can travel in a straight line and are reflected by the conducting surface. Microwaves also are easily attenuated within shorter distance, and the current can flow through a thin layer of a cable. Now, let's see the advantages and disadvantages when using microwave communication. One of the advantages is its relatively low cost. Microwave communication systems have relatively low transaction costs compared with other forms of data transmission such as wireline technologies. A microwave communication system does not require physical cables or expensive attenuation equipment. Mountains, hills, and rooftops provide inexpensive and accessible bases for microwave transmission tower. Microwave also can transmit large quantity of data. Microwave radio system can broadcast large quantities of information because of their high frequencies. Microwave radio communication system propagate signals through the Earth's atmosphere. These signals are sent between transmitters and receivers that lies on top of the towers. This allows microwave radio system to transmit thousands of data channels between 2 points without relying on a physical medium like fiber optics or wire cable. For disadvantages, we have solid objects. Microwave radio systems do not pass through solid objects. This can be problematic in cities with a lot of tall buildings or mountainous region if you want to send a signal from one end of the city to other. There are ways to work around this, like erecting repeaters between two towers if an object is blocking them. Signal can also be bounced off solid object and even the ionosphere. It's even possible to bounce microwave off of the moon in Earth-Moon-Earth communication known as moon bouncing. Microwave is subject to electromagnetic and other interference. Electromagnetic interference or EMI can obstruct or degrade the performance of microwave signals. Electric motors, electric power system lines, and wind turbines can all emit EMI that disrupt microwave communication. Wind turbine, for example, scatter and diffract TV, radio, and microwave signals when placed between signal transmitter and receivers. Microwave radio communication can also be degraded by heavy moisture in the atmosphere, snow, rain, and fog.
Clearly, most people are already using microwave communication in more ways than they realize. If you own a cell phone or pay for satellite TV and radio, you are depending on microwave communication every day. Now, thank you for your time. For further information, you can visit the links in the descriptions, and don't forget to like and subscribe.